All right, let's get going. So today I'm going to be talking about object-oriented JavaScript. This is relevant to one of the earlier modules in this phase about, I think it's called like advanced JavaScript or digging deeper in JavaScript. I forget the exact name actually. Call that thing. Curriculum. It is this one, digging deeper into JavaScript. A good bit of this is about object-oriented JavaScript, things like this, the keyword this. So this lecture will cover a good bit of that. There's some stuff in that digging deeper section that we're not going to talk about today. This is going to be a general introduction to object-oriented programming in JavaScript. So let's get going. As usual, please feel free to jump in with questions as you have them. And oh, and can everybody hear me now? Somebody says that yes. Okay, good. Yay. Yeah, I was probably muted earlier. All right, so object-oriented JavaScript. So object-oriented programming is a programming style or paradigm that has been really popular over the past, I don't know, a couple of decades. It's centered around this idea of an object, where an object is defined as, you can think of this as like an entity. It's like a thing in your program that combines data and the code that operates on that data. Sometimes you'll heard this stated as it's a combination of state and then a predefined set of methods that like mutate that state. And this is a feature of a lot of programming languages. Some programming languages don't support this at all out of the box. Some of them are sort of built so that the only way you can write code is in an object-oriented manner. Every piece of code you write has to be part of an object. JavaScript falls somewhere in the middle, where you can write JavaScript for a long time without really knowing anything about object-oriented programming, even though you'll interact with objects here and there, or you can sort of write all of your code in an object-oriented manner. So if you're in phase 2 here, it's possible that you got through phase 1 without really knowing much of anything about object-oriented programming, or maybe you've had more exposure to it. I'm going to try not to assume too much going into this lecture. So this definition is pretty vague and not grounded. So let's look at some actual examples. So you've probably interacted with objects already in JavaScript. You most certainly have. Obviously, there's the thing in JavaScript called an object, and you've certainly used those if you've written any amount of JavaScript. You're also familiar with things like dates and arrays in JavaScript, and those are also objects. And so, for instance, let's look at object in JavaScript. So we have this. Oh my, somebody added animations. Did not mean to do that. So we have this concept of an object in JavaScript, and you're probably familiar with it to this extent, right? So we can use the curly braces and we can create this data structure and assign it to a variable pets, right? And an object has these properties. They each have some value, right? So we can create an object that represents like our pets and have properties for each type of pet with their name, right? So you're probably familiar with this. The other thing about objects, right, is that these types of objects in JavaScript is that in addition to the properties that you define, right, so we can access properties using this bracket notation or this dot notation. You'll also see functions being called sort of attached to an object. So if we say pets.toString and then we call that function with the parentheses, we'll get this string back. It's sort of this string representation of the object, which by default is not super helpful. It's just kind of showing us that this thing is an object. But this toString, right, we're calling it as though it were a property on this object, but it's not a property that we set. And this is an example of a piece of code, this toString function, that's being sort of encapsulated with this data, the dog and the cat properties, to sort of operate on the object as a whole. So it prints out some string representation of the object itself, and it's sort of this toString method is bundled with the pet object. So you've probably seen this in a couple different scenarios. If you've played with the date object at all, you'll if you were sorted into phase 2, then you might not have done the phase 2 interview. But if you've done any of the like phase 2 interview challenges, you probably had to use the date object and call something like date.getMonth or getDay, which is another example of like a function that's like attached to a piece of data. In that case, a date that represents the date. So other interesting examples would be an array. So you're familiar with creating an array this way with the brackets. We're just calling it nums here. It's an array of numbers. We know we can get an individual number out of that data structure by using the brackets, right? To get the element in with index 1. You know, we can do this to get the second element, which is 5. But then this array also has other properties like .length, which will tell us how long it is. And the array also has functions like .filter that allow us to, filter out different elements of the array based on some test function that we pass in. It's also the .sort method, which sorts the array, returns the sorted array, and also actually manipulates the array itself. So that after we call nums.sort, if we just look at nums again, now it's in a different order than it was before. So an array in JavaScript is another example of an object. And you can kind of see here how it sort of encapsulates, this array object encapsulates this data, which is these 4 numbers, and a bunch of functions that can be applied to that data to change it in different ways. So we're not actually passing in any arguments to sort. Sort is just operating on the object it's being called on. And that's sort of what we say when you do like object dot and then some function. You're saying you're calling that function on that object. And so shouldn't dog be Rex? Did I get something wrong on my last slide? I probably did. Yes, that's what I get for changing my examples halfway through. That should be Rex in that slide. Thanks for catching that. So, so that leads to the question, like, how do we make our own objects, right? You sort of interacted with these built-in things, but if you're gonna actually write your own object-oriented code, you're gonna need to write your own objects and organize your own code into that sort of object paradigm. So how do we do that? Well, this syntax, going back to the initial example with the pets, right? This syntax should look vaguely familiar. All right, if we drop the, if we replace the individual names, right, with just something generic, right, we're familiar with this syntax, object.method. If we drop the parentheses, that starts to look really familiar, right? It just looks like we're calling a property on an object, right? We know we can get an object's property by just saying object.property name. And that's basically all that's happening here, right? We are creating an object. So for instance, we could create an object called fancy list that has a property nums that has that list that we were looking at. And then we can create other properties that are themselves functions, right? The value of the sum property is just this anonymous function. And this anonymous function is using reduce, which is an array method, to sum up all the values of the array. And I'm going to gloss over reduce right now. If you're not familiar with reduce, it's super fun and it's worth checking into. It's really powerful. But the important thing here is that in this function, we're using the keyword this to refer to the object that this function is being called on. And what JavaScript does for us is if we reference this sum function by saying fancylist.sum and then call it that way. So we say fancylist.sum with the parentheses to actually call that function. In this syntax, JavaScript will set the value of the this keyword to be a pointer to the object that sum was called on. So in this case down here at the bottom of the slide, this would be set to fancy list. It's going to hold this whole object, allowing us in our function to access properties of that object. So we can get to this.nums to get that array back and then call reduce, which is an array method on our nums array to do that sort of summing up. So this is pretty similar to JavaScript syntax you are probably familiar with. And it's just adding this, this keyword to our lexicon. And so at its simplest, this is, object-oriented programming in JavaScript, right? We've got an object, we've added a function to it, so now we have some data and we have a function that operates on that data, and they're all sort of like packaged together in this one big object. And they let us do things like this. We can pass this fancy list around, and anybody who wants to get a sum of the list just has to call .sum on it without having to worry about like the mechanics of how should we add all those numbers. And we could add other helpful array-like methods to this if we wanted to, that aren't built into the JavaScript array. Any questions on this part? Before we build on it, we're going to kind of see better and better ways to do this.
So .sum returns an array.
Yeah, .sum, when called like this, returns it returns a number. It returns the sum of all of the numbers in the array.
Okay.
That makes sense. And that's because that's what this.nums.reduce. Reduce is an array method that takes an array and reduces it to a single value.
Yeah.
And in this game, you kind of pass it a callback function, sort of like you do to filter, to tell it how to go about reducing many things into one. I'm just sort of glossing over that a little bit, but this is how you would reduce to just sum up all of the numbers in the array and get like that one number out. It's just the sum. So you can think of this reduce as the same as if we had like a for loop that just looped through each number in the array and kept adding it to a total until it was all the way through the array and then returning the total. This is just a kind of a quick one-line way to do that.
So Trevor,
yeah.
Just to be clear, in this situation, this is referring to fancy list?
Yes, that's correct.
Okay.
Mm-hmm.
Okay, yeah, I just wanted to make sure.
Yep. Mm-hmm.
Hi, Trevor.
Yeah.
Hi, I was wondering, so I understand that there's, the value of this depends on how you declare the function. So if you had used the arrow function, the value of this would be different. Is that relevant here?
It is relevant. Yeah, it's probably more detail than I was going to go into at this point, but that is true. So it's important here that I use the function syntax here, where I type out function parentheses. If you use an arrow function here, arrow functions behave a little differently when it comes to the value of this. So because I declared this function this way using the like full typed out function syntax, I get that behavior that when I call fancylist.sum, JavaScript sets the value of this inside the function to be the object that the function is being called on. But if you use just the arrow syntax for a function, you lose that bit of magic. So this is one case where you actually do want to, there is a difference between using the arrow version of the function and this full-on version. That's a good question. Yeah. Any other questions? Okay. Stop me if you think of anything. So, so this thing we're doing here, like this is nice, but it's a little bit awkward, right? I don't want to have to write this whole object and type out this whole function every time I create one of these lists and want to be able to sum it up. this works, but it's not very useful. I'm having to hard code this big old object every time I want to create one of these like fancy list type objects. So what I could do is I could just create a function called fancy list that just takes in the array and then returns a new object that has that array in a nums property and then has this sum function attached to it as another property. And then I could just call it down here like this, right? So I could create a list called mylist by calling fancy list and passing it in this array of numbers, right? And then I have this object mylist that I can call .sum on, and it'll sum it all up. And you could imagine, again, like we could add any number of functions into this object here to maybe find the maximum value of the array, find the minimum value of the array. You know, we could build sort of a replacement for the built-in array in JavaScript that adds some of the things that like the JavaScript array doesn't do for us. So this is a little bit more of a reusable way to do it. And this is getting us closer to probably what the recommended way to do it is.
Trevor?
Yeah.
Do you mind if we look at the first way first? Because I just want to compare.
Yeah, So this is the first way where I'm just declaring a constant for my list. And setting the property of nums explicitly to this hard-coded array. And setting sum to this function. And probably a better way to describe this, actually. Excuse me for a second. These will probably make more sense together if we call it this, my list. So here I'm wanting to sort of create this object to represent a list of these numbers, and I want to be able to sum it up just by saying like .sum. And so I'm doing that sort of all by hand in this example. And in the next slide, I've created a function that builds that object for me, which has the same result. I can create my list by calling fancy list and passing in that array. So the result is the same, but this allows me to create lots of these. And probably a better motivation for this is if I had a couple of different lists, right? You know, maybe this list has different numbers in it.
Oh, okay, because it's not hard-coded.
Right, it's not hard-coded, so now I can use this fancy list function. I can use this fancy list function here to sort of build these fancy list objects, right, that represent a list but come with these special methods added onto them that I can call later.
Okay.
Does that make sense?
Yeah, thanks.
Yeah.
Can I ask you something? On line 1, 2, 3, where you say just nums, is that short form of saying nums, call nums? Okay, cool.
Yes, yeah, it is.
Thank you.
Yeah, you have the capitalization there. Yeah, that's the same. It's just a shortcut. All right, so let's go back to big slides here. Here we go. All right, so it turns out that JavaScript has another little piece of syntax that makes this type of, creating functions that return objects that have like special methods attached to them. There's some syntax to support that. So in this case here, the only thing I've done here is change the capitalization of fancy list. So the name now starts with an F. That doesn't do anything in JavaScript. It's just a convention. But it's a very similar function, but I'm using this in this function instead of like creating an object on my own. I'm assuming that this already holds an object, and then I'm attaching nums to it and sum to it using the typical like object dot property equals notation. This is called a constructor in JavaScript. So a constructor is a function in JavaScript that you use this new syntax to invoke. So instead of calling the function normally, as I did in the last example where I just said fancy list and then passed into some parameters, if I say new fancy list and then pass in parameters, when JavaScript runs this fancy list function, it'll run it as a constructor. And what that means is it will set the value of this to a brand new empty object for me. And then it will automatically return that object after the constructor runs. So that means I can take this, which holds this new empty object, and I can set some properties on it, like nums and this sum. And then even without specifying a return statement at the end of my function, the value that's in this will automatically be returned from this new fancy list statement and assigned to my list, down here where I say const my list. So this is sort of the sort of like officially supported JavaScript way of creating an object. This is the kind of the full syntax they give you for this to make it a little bit easier. So now I basically have this new data type called fancy list, and I can create fancy lists and use them. And this should look really familiar if you've ever created a date object. You've used this exact same syntax, new date, and it's exactly the same thing. Does that make sense? Any questions about that? Okay, cool. And the other thing to be aware of about these constructors is that, so this new fancy list syntax, all the other times that you're using objects in JavaScript, so for instance, let me just add a new slide here to give me somewhere to type. When you do something like this, let object equal, let object equal a new object, capitalization. When you do that, it's exactly the same as doing this. So you could replace this first line with this second line, and you get basically the same result in OBJ. This curly braces notation is just a shortcut that JavaScript provides to make creating objects of this sort of like base object type really easy.
And that's the same thing for arrays, correct?
That is correct. Yeah. So yeah, for arrays, you typically use this like square brackets. But you could also say let new, let array equals new array. You'd have to spell it right. It's very picky about the spelling. Yeah, so those two things are exactly the same. These curly braces and square brackets are sometimes referred to as like object literal notation. So you're just like literally typing out an object or an array, but they are shortcuts for these like new constructor forms of creating objects and arrays. So there's a couple problems with the way we're using this constructor here. And part of it is this, you know, in our constructor, really all we're doing is like setting this value of nums to nums. But then we've got our function, our sum function is sort of embedded here in our constructor. And one of the problems with doing it this way is it's a little bit of a technical problem, but there are performance problems with defining this function here. What this means is that every time someone calls new fancy list, every time I create a new fancy list object, my constructor function gets called, and JavaScript has to go to the work of building this function again. So this sum function, every time the constructor runs, this anonymous function gets defined and stored in sum. And so I'm just creating this exact same function over and over again each time I create a new fancy list. You can imagine if I was going to create, you know, maybe 50,000 fancy list objects in a loop, having to create this function 50,000 times is going to slow me down. And it's a little useless because it's just the exact same function being created over and over and over again. So we would like to have a way where we could say, hey, any object that I create using this fancy list constructor should have a reference to this sum function in it. But I only want to create this function once, and I just want all of those fancy list objects to point to it. And that is where prototypes come in. So it turns out that when you call a constructor, the value that gets stuck in this, it is a new object, but the shape of that object, the properties that that object has, are based on what's called a prototype. So functions have a property called prototype. So in this case, my fancy list function, which I can reference just by saying fancy list, just like any other variable in JavaScript, it has a prototype object, and I can add attributes to that prototype. Oh, wow, did not mean to do that. I can add objects to that, I can add objects to that prototype. So I can add properties to that prototype, and all the properties that are in the prototype will get added to any objects that are created by the constructor. So when the constructor is called, this will get populated with a brand new object that has all of the attributes that the prototype has. So that lets me define that sum function by saying fancy list.prototype.sum equals and assign it to that anonymous function. And this code will behave in terms of the object that it creates identically to this constructor over here where I'm saying this.sum. You'll see both methods of doing this in the wild. You'll see people defining functions this way inside their constructor and just assigning them to this dot function name. You'll also see it happen this way where those functions are getting added to the prototype, and we're just relying on JavaScript to add all of those prototype properties into the object that gets initialized as this in the constructor. Does that make sense?
Can you
yeah, go ahead.
Can you please repeat that, Trevor?
Yes. So when you use a constructor to create an object by saying new constructor name, JavaScript will initialize an object. It'll create a new object, and it will make this inside the constructor a reference to that object, right? The object that gets created and put in this in your constructor will sort of inherit any properties that the constructor's prototype has.
Yeah.
So the constructor, fancy list, has a prototype property, which is an object. And you can add properties to that prototype object, like I'm doing here, adding a sum property that points to this sum function. And when the constructor gets called, when JavaScript goes to create an object to initialize your this in your constructor, it will add into that object any properties that exist in the prototype for that constructor. So you can think of the prototype as sort of like a template or like a blueprint that says, okay, any fancy list objects that we create are going to have all these properties.
Gotcha.
So any properties that aren't based on values passed into the constructor, and functions are the prime example of that, right? Your functions are going to be the same no matter what the values passed into the constructor are. You can define on the prototype here. And it's a little bit of an efficiency gain, and it has some other nice properties when you start doing more advanced stuff with object-oriented JavaScript. Having all of your functions defined on the prototype can be useful in other ways as well. Is that helpful? Was that better the second time?
Yeah.
Yes, it was.
Go ahead, Shasha.
No, I was saying yes, it was. It was helpful.
All right. So I understand that there's a way of defining classes in JavaScript by just using the keyword class. Do we prefer not to use that and use the function keyword in order to make classes?
So the class keyword is newer. I think it's ES 2016. And this is definitely not an endorsement here of saying, oh, you shouldn't use class, always use this function syntax. This is just, class gives you like a cleaner syntax for doing the same thing. So it's functionally more or less equivalent. It's just hiding some of the slightly uglier way that you have to do this with constructors. It's sort of abstracting some of that, some of what's going on.
Kind of like for each and a for loop.
Yes, yeah, sort of like that. It's sort of just like a layer of abstraction to make the syntax nicer. I really do like class and defining classes that way, partly because it looks a lot more like object-oriented code in other languages, and this like prototype stuff is a little awkward. So I will not steer you away from using class. It's just that it's not always available in the environment that you're running in. It's, you know, in a lot of browsers, it's going to require you to have like Babel installed or some sort of like transpiler to take that JavaScript and like translate it into JavaScript that older browsers will understand. And you'll come across JavaScript that's written this way that sort of predates class and the ability to define classes that way.
So we should just get in the habit of using the capital letter, like for fancy lists with the capital F for prototype.
Yeah, so right, the capital letter here is a convention. So by convention, in most JavaScript code, if you're writing a function that you intend to be a constructor function, you start it with a capital letter. It's not telling JavaScript anything about this function. Like JavaScript doesn't care if it's uppercase or lowercase. It doesn't know the difference. But it's just it's a hint to other people reading your code that like, oh, this is a constructor function because they capitalized it. What makes it a constructor function actually is the way that it's called. You can say new fancy list. This is what forces JavaScript to trigger that behavior with regards to the this keyword and like setting this to be a new object and returning it automatically. That happens because you call it with new in front of it. But having the capital letter in there is just it's a convention that is followed by most folks.
So would you say this is what would be referred to as prototypical inheritance?
We're not actually doing any inheritance yet. But well, I guess maybe we are, yeah. So inheritance comes in when you create an object and then you want to create like a more specific, let me say this the right way. You create a constructor that creates a certain type of object, and then you want to create a new constructor that creates maybe a more specific version of that type of object. But I think to talk about inheritance, I want to actually open up an editor so that we can see that a little bit more. Let's do this. Can everybody see code now?
Yes.
Okay, great. So here's our fancy list constructor in my editor. Let me think of a good example. Always takes me a minute. So let's say that you had, so we have this fancy list that adds this sum method. And this is not a great example of object-oriented design, but just for the purposes of showing inheritance. Let's say that you, well, let's change the example so the inheritance makes more sense. So let's say we had a vehicle constructor, right? We're gonna create a vehicle and it's gonna have right now we'll just say it doesn't take any new parameters, right? We're just gonna create a vehicle constructor. And we're gonna change this to vehicle. Every vehicle is gonna have some method called start. And maybe each vehicle will have some state called running that starts out as false. And the start function will just say, it says name equals true. So let's say that we want to create a specific type of vehicle, right? We have this vehicle object, this vehicle type, I guess we might say, that can start, and maybe let's say it can return a status, let's say. So we could say if running, return running. Otherwise, we'll return not running. So we've got this object that has this behavior, right? And if we, let's see, I'm just gonna copy this into this node terminal down here. So now we should be able to say let equals new vehicle. We can create a new one. We can check the status. It's not running. And then we can say v.start. And now the status is running. So you have this nice like vehicle functionality. It's going to apply to sort of any sort of vehicle we might have. And now let's say that we have a need for a car, right? We want to create a specific car class that's going to have some added behavior, right? So our create a function for cars, or let's call it a sports car. Let's say that sports cars are going to have a new method called go fast. Sports cars can go fast. Not all vehicles can go fast, but sports cars can go fast. This is prototype. So we create this prototype go fast. We create this method, and let's just say that it makes the car go really fast. So that's nice. We now have a sports car, and if I paste this stuff into my REPL here, I can say let sports car C equal new sports car, and I can see that sports cars can go fast. That's fantastic. What I can't do with my sports car is start. And I can't get the status to see if it's running. Right? Because those functions are not part of the sports car. They're up here in the vehicle. So I would like an easy way to say, okay, sports car is just a specific case of a vehicle. Sports car should inherit all the behavior that a vehicle has and then add its own special sports car abilities. So what I want to do is I want to merge in all the values from the vehicle prototype. I want to include all of those in my sports car prototype. And so what I'm going to use for that, there's several different ways to do this. And what I'm going to use is something called object assign. Yeah. So there's this built-in method called object assign that will take a number of objects, and it will it'll basically merge those objects together. So what happens is, and maybe it's easier to show if I say this, let's say var result, create an empty object, and then, so you give it an object, and then you give it a bunch of other objects whose properties you want merged into the first object. So result is empty when it starts, and then I've got this object with an A property and an object with a B property. And after I run object assign, result's going to be updated to have all those properties, A and B. So this is one way I can do prototypical inheritance here, right? Is I can take the prototype for vehicle and I can merge it into the prototype for sports car. Object assign sports car prototype, right? And I want to add into that the vehicle.prototype. So, and we have all this stuff defined in the REPL already. So if I just take this one extra line, now if I create a new sports car, new one, new sports car. So sports car 2 should be able to start. And it now has a status and it can still go fast. So that is an example of prototypical inheritance, where we are taking where we're sort of inheriting prototypes. We're merging prototypes together to sort of combine the attributes of a lot of different objects into one. And this is where, yeah, somebody have a question?
Yeah, I wanted to ask, so is this just a good way to do it? Because I think we're copying the entire prototype and merging it into the sports car prototype. Is there a way to say, if you don't find this stuff in the sports car prototype, look up for the vehicle prototype? So if you don't find it in the sports car, look for it in the vehicle. Or I don't know if there's a way to do that.
Yeah, so unfortunately, I don't think that's built into JavaScript. A lot of other languages do it that way. They'll just like start searching up a tree of parents. And that's one of the different things about prototypical inheritance, is that you're just like, you're creating this prototype and then it gets used when the object is created. So the timing of things is a little bit different, and there's not this sort of like, let me go search for this method when the method is called. It's always just going to go look in the prototype, and the method's already either there already or not. Yeah. However, just to the larger question of like, is this a good way to do it? There's lots of different ways to achieve this in JavaScript. And you can kind of see that, right? That these prototypes are just objects, and so you can just kind of treat them as objects and merge them together and like add things to them. So there's lots of different patterns that people use for creating constructors and prototypes in JavaScript. This is sort of like the plain vanilla way to do it. But as somebody mentioned, JavaScript now provides an alternative syntax, JavaScript class. I almost spelled that right. That sort of hides some of this messiness from you. And this is what it looks like here. So what I can do, I can rewrite all of this, assuming I have all this available in my environment, which I think I do. Let's create a new file called FancyList3 and rewrite some of this. So I can just say class vehicle to create the class, and then inside the class, declare my constructor this way, where it will almost look like, it'll look a lot like a function definition, right? And then my start method can also be down in here, and I can just say start. This running, and the status method I can take up here as well. So that should be roughly equivalent. Let me hold off on sports car for a sec. So I can take this class, and let's copy that into our REPL. Let's start a new one just to make sure we're not. So I can create this class, and now I have a right, so let v equals new vehicle. So it works exactly the same way, but I have this, what some would argue is a much sort of saner syntax for doing that, right? You're not like creating some function and then adding this weird stuff to the prototype. So I would say the syntax is just a lot clearer what's going on. But I kind of want to introduce you to the other way of doing it, since you will see that other way in JavaScript. And at this point, that other way may still be more common in a lot of JavaScript libraries that are written to sort of target older platforms or just people who were writing code before this was an option. The other nice thing about this class syntax is the inheritance gets a lot cleaner. So if we do this to the sports car class, and let's see. Should be able to, let me check my syntax here. Boom, boom, boom. Prototype method, static methods. Subclassing with extends, here we go. So you can say extends and then another class to get that same kind of behavior. So we can say sports car extends vehicle. And if we copy this into our terminal here, we should be able to say, let some sports car be a new sports car. And we get that status method for free, right? We get that same sort of inheritance behavior where we get the vehicles methods as well as the sports cars methods. So this is clearly, I say clearly, maybe it's subjective, but to me this is a lot simpler. It's way easier just to say extends vehicle than to have to like go pull in like object.assign and like merge these two prototype objects together and stick them in the other prototype. And this is definitely a much saner syntax for the same thing.
So Trevor,
Yeah.
you would definitely recommend that we learn both ways and not just this way?
Yeah, I would. I feel bad saying that because I know it sucks. But I think that just because of the state of JavaScript right now, it's very helpful to know what some of these like pretty new toys that they're giving you are really doing under the hood. Because you'll still, what happens is this, if we look at sports car, sorry. If we look at sports car, you'll see that this sports car variable here, it's still a function. It's still just pointing to a function. Even though I used class to define it, it still comes out as a function. It's still going to have a prototype, pretty sure. Yeah. So I think it will end up serving you well to sort of know a little bit what's going on beneath the hood. I would not say you don't have to know them all like by heart or exactly, because you don't have to use them. You don't have to use both of them. Like in most cases, if you're writing your own apps, you'll probably be able to set up, either use a version of Node that supports this, or use a Babel or some other transpiler for your browser side code to allow you to write your code this way and just transpile it back to the old versions. So it's probably okay if you're a lot more familiar with this class syntax in the long run. But I do think it's worth spending a little time just to familiarize yourself with the constructor function version of creating objects, just because you'll encounter that code a lot and have to be able to understand what's going on. And it may help you when you're going in to try and debug some of your own code, even if you've written it with this class syntax, just to sort of know what's going on underneath the hood. I think it's helpful.
Okay. Thanks.
Yeah. Any other questions?
Well, I don't know if you want to talk about what is it called? There's inheritance and there's so you only inherit like, I forgot the keyword, but it comes with object-oriented programming a lot.
I'm not sure I followed the question. What were you asking about?
Okay. I forgot what it is called, but it's like you only want your child classes to have access to certain methods. Honestly, I'm not sure about like the keyword. I can look it up and let you know. But hold on.
Yeah, your child class. Are you talking about like public and private methods, or?
No, polymorphism. Okay, yeah, I'm talking about polymorphism.
Yeah, I'm not exactly sure what you're getting at. I think polymorphism might be a little bit different than what it sounds like you're talking about. Polymorphism in general is just the idea of having, let me just think if I can think of an example. So the idea behind polymorphism is that you have multiple objects or multiple types of objects that have the same, implement some of the same methods, have a same interface, have a similar interface, so that you can write functions. So for instance, I could write a function that just takes a vehicle. And this isn't specific to object-oriented programming, but you hear it a lot as a benefit of object-oriented programming, is that I can have this function that takes some vehicle object and knows how to start it, right? I can call vehicle.start. Maybe it's doing other things. This function can be said to be polymorphic because you could also pass a sports car into this function. And because sports cars have a start method, which they inherited from vehicle, sort of any vehicle or subclass of vehicle is going to work if you pass it into this method. And that's sort of where polymorphism comes in. a little bit. But I'm not sure how that relates to like child classes only having access to certain things from the parent.
Yeah, I think,
don't know if-
yeah, whatever you just said sounds about right. I think I was getting confused between polymorphism and something else.
Gotcha.
Yeah.
Okay. Right. Well, we are getting close to the hour. Any other questions, comments? This is just going to kind of scratch the surface of object-oriented programming in JavaScript. I know there's a lot of topics that we did not get to. And maybe I'll do a follow-up lecture sometime later this week or next week to try to get to some of the more advanced topics. But I kind of wanted to do just a little bit of an intro.
Trevor, this is the first one you've done, right, on this topic?
Yes, I know I talked about like this and apply and some other related things, but I think it was in an office hours. I don't think I've done a lecture.
Okay.
I'm pretty positive I haven't done a lecture on object-oriented JavaScript yet. Yeah.
Okay. Are you going to post it this afternoon?
Yeah, I'll upload it as soon as it's ready. So it'll be up this afternoon or tomorrow morning at the latest.
Okay,
Sometimes
great.
it takes a while for Zoom to like compile the video, and so I kind of got to wait around for that to happen. But it should be up by first thing in the morning at the latest.
Okay. Thank you.
Yeah. Thanks, everybody. I'll talk to you later.
Have a good day.
You too.